Hi everyone. So today we're going to solve Leetcode daily challenge, problem number 2359. Find closest node to given two nodes. So the problem statement is really long, but the task they want us to implement is really simple. So we will be given two nodes, one like node one and nodes two, and we have to find out the node which we can reach with the minimum distance. And if there are multiple nodes with the same distance, we want the node with the smallest index. And they have given the inputs in this structure. Node 1 and node 2 will be given with the values node 1 and node 2, of course. And edges represent basically the connection between, for example, at this, if you want to read this array, uh, zeroth node has a edge with node 2. Okay. Similarly, the node 1 or index 1 had a edge with node 2. Node 2 has an edge with 3. Node 3 doesn't have any edge. Basically, minus 1 represents no outgoing edges. And it is given that we can have at most one outgoing edge. Okay. So we are good till this point, and this is it. This is the simplest way to understand the problem. And I have used a very naive approach to solve this because it was the simplest one I could think of and worked really well. So what I'll be doing is I'll be checking out or I'll be figuring out what all nodes I can visit from both the given nodes. For example, with node one, what all are the nodes which I can visit? With node 0, what all are the nodes which I can visit. After that, I'll just simply, and of course, I'll keep a track of the distance as well. And after that, I'll just simply take the intersection of the common nodes. Okay. And after that, it's gonna be very simple. Just run a for loop and find the minimum distance, the node with the minimum distance which we can reach. So let's move to the solution now. Okay, first thing which I want to do is I want to check an edge case where if they wanted to have some fun with us, they might have provided the same nodes in both, right? If node one is not equals to node two, then I want to return anything like either node two or node one. Okay. Next, I want to check all the nodes which I can visit from node 1. Index system going to represent that, and I'm going to store the values in like this format. For example, I can visit 2 with a distance of 1. Okay. Next thing is I want to keep I equals to node 1. Basically, I'm just initializing the variables right now because, for example, distance from node 1 to node 1 will be 0, right? To support that, I'll initialize my distance with 0. Next thing is I want to check while I not in index visited one. Basically, till the point if we haven't seen the current value in already visited checklist, we will move in the loop and I is greater than equal to 0. Sorry. Yeah. Once we enter the loop, I want to update my hash. So as we know, we wanted to store the value or the index with the distance, right? So my current index index is I and my current distance is test. Once this is done, I want to update my I to the next node which I can visit. So this will be represented with edges of I, right? And we will simply just implement the distance with 1. We will have to follow the exact same code for to figure out the nodes which we can visit from node 2. So yeah, this is done. Yeah, it was very simple. Like I just simply copied the exact code which we have used for to figure out the nodes which we can visit from node 1. Now the next part was figuring out the common nodes which I can visit from both the given nodes, right? So to do that, what I'll be doing is I'll be figuring out the intersection between the keys of these two hash maps which I have used. And to do that, let's take the set because you cannot directly apply intersection on the list. So let's take a set of list of keys from index visited one and intersect it with I think it's intersection of set of keys of index visited 2. So this line will basically give us the common nodes which we can visit using the given two nodes. After that, I'll be initializing a variable minimum distance, and let's initialize it with infinity. Okay. And they have given that if there is no common nodes in the question like it's mentioned, I want to return -1. So let's initialize result equals to -1. Yeah. So this part is solved. Next part was we wanted to run a loop in the common nodes or iterative in common nodes. So I'm iterating among the common nodes which we have, and I wanted to check if like the maximum distance to reach this particular node from node 0 or node 1 is less than the minimum distance, current minimum distance. If yes, I want to update my result to the current value, and of course, like minimum distance will get updated. So instead of just directly putting it over here, let's create a common variable, current distance, let's say. Okay, current distance will be maximum of index visited one with the key iterator, and the second parameter will be index visited two for the same key. Okay, so if current distance is smaller than minimum distance, if it is smaller than minimum distance, yeah, I think that is fine. Then I want to update my result to the current value, take iterator, and I want to update the minimum distance to current distance. This part is done. There is one more condition where we have to return the smallest number if there are multiple nodes with the same distance, right? So if current distance is exactly same as minimum distance, then I would check if current iterator is less than the result, then I would like to update my result to iterator. And this is done. At the last, I would just simply return my result. Let's check out the test cases. And I think this part can be more optimized, but let's see. Okay, so the test cases got clear. Let's submit for further evaluation. Yeah, so the solution got accepted and we outperformed 86.78% of the submitted solutions. So yeah, thanks everyone guys for watching out the video and stay tuned for the upcoming. Thank you.